All right. Hi, everyone. Welcome back to the IHCC cohorts meeting. So I'm Thomas Keane. I'm gonna be chairing a session about a discussion session, really to talk about leveraging cloud infrastructure for your cohorts, for hosting the data, for serving the data. And I'm really interested to get a sense for the audience. So we do have a poll with a couple of different questions that you should start to appear on your screen somehow magically by our organizers. And it really is. It would be great if you could answer some of the poll questions. They're really quick, easy questions. Just trying to get a flavor for the where you are in terms of your use of, if you're interested in using cloud, what might the barriers be? Maybe just to give us a sense of where all the participants at the meeting stand in terms of interest in cloud infrastructure and use. So please, if you can, to answer some of the poll questions, that would be really great, because that would be really informative for the panel for our discussion that's coming up in the next 20 minutes or so. So maybe just to start off, I'll just introduce some of our panelists. So I'll start with how I can see them on my screen. So first up, I'll start with Augusto. So we've got Dr. Augusto Randon, who's a chief bioinformatician for Genomics England. So maybe Augusto, if you want to just do a brief introduction, a few minutes, just to give us.
Yeah, sure. Great. Yeah, my name is Augusto. I have been with Genomics England for just over 8 years, where we have a process where we provide clinical whole genome sequencing for diagnostic purposes, and then with consent, we make those data available for research. Cool. Thomas, do you want me to go into kind of a longer description or just an introduction now?
Oh, yeah, no, you can take
cool.
3 or 4 minutes. Yeah, go for it.
Okay, cool. So I can tell you a little bit about our journey. So we currently have thereabouts of 180,000 whole genomes, and we also have clinical information, a number of omics data sets, not for all of those samples, and also pathology images. Altogether, that is about 60 petabytes of data, and we maintain that triplicated across 3 sites. We have undergone a transition to the cloud. So on top of the data and the compute, we also have, of course, applications that run around collecting those data, ordering tests, and so on. And so we have migrated to the cloud all our applications. And so only currently HPC and storage remain on-prem. We are developing a hybrid strategy to be able to benefit from both that on-prem compute and storage, but also be able to, in some ways, scale out to the cloud, particularly for 2 use cases. One is in terms of resilience as a clinical service. We want to make sure that no matter what, we're able to provide that service. So if our on-prem environments are down, we would like to be able to continue processing genomes, but also to enable researchers to run more complicated, bigger workflows without having to wait for each other as you would do in an HPC. However, we're still exploring the economics of that, and definitely the answer is not a single one at the current time. We find in terms of adopting the cloud, the most difficult part is some of the expertise required for that, and specifically networking, firewalls, those sorts of things that have always been difficult. They are still difficult in the cloud, and they're so crucial to ensure that our data is secure. I think nowadays finding cloud engineers that teach you how to use those or that know how to use the cloud is okay. It's that networking firewall side of things. One of the big benefits we've had with the cloud is on the engineering side, and it's just that pace of development of putting new applications, new solutions, new test environments that becomes much more kind of acceptable in terms of the times that you want to deliver value to your users. And then perhaps I'll finish by saying that we have currently 2 research environments, one old one that started on-prem. We've migrated the applications and databases to the cloud, but still the HPC, as I said, is on-prem and the storage. And then we have a fully cloud-based research environment, and we are in the process of merging them. We've seen that There's just a need for users want a combination of those types of technologies. And that's me.
Great, thanks for that summary, Augusto. It's some interesting points you've made already for our discussion. So we'll do questions from the audience after we go around our panelists. So next up, I've got Dr. Emily Jefferson. Emily is the Chief Technology Officer for HDR UK and the Chair of Health Data Science at University of Dundee. So Emily, over to you.
Yeah, hi everyone. I've only just joined HDR UK as their CTO, so I'm going to give you a couple of examples of some other things that I've been doing over the last little while. So up in Dundee, we run what's called a regional trusted research environment, otherwise known as a safe haven to some people. And Augusto was talking about an environment that you can get genetic data in a sort of trusted research environment. So we've been running for kind of observational studies and linking health data with education data and police data and things for probably over a decade. Well, no, for about 15 years actually. But in the last few years, we've invested a huge amount of work to try and see how we can move from our existing private on-prem cloud into the public cloud and create a trusted research environment that can be scalable and also support AI development within that environment, more support for researchers to install all of their own tools and their workflows, and also for multi-omic data. So what we're trying to do really is bring the worlds of kind of really sensitive data, lockdown clinical data analysis with the world of bioinformatics, which wants big data and big data analysis and AI and things, and bring those two different worlds together so that they can actually coexist within the same environment. So still put the same kind of controls in place, but actually give the researchers the same functionality as they really need, even though you've kind of got a lockdown system. So we did quite a bit of research in actually looking at the real costs of managing an on-prem solution with, the amount of it would cost us to replace very aging servers, the amount of work that we'd have to do in terms of staffing time and compute time, and also the kind of the spikes of usage that we were seeing. So sometimes our machines would be absolutely thrashed for a few days while people ran some things, and then they'd be quiet for quite a time, and then they'd be thrashed again. So looking at all of the different usage patterns, staffing patterns, and real cost for maintaining those sorts of systems, we actually worked out that going into the cloud would be quite a good solution for us. And it would also mean that we could enable an environment where people could, on demand, have as much compute power as they want. So they don't have to wait a week for things to finish. They can just do it in a much more parallelized fashion and just have a massive spike basically in order to do things. And it also meant that we could get a lot of the pipelines and things that were out there kind of readily available and easily configure them within that environment. So that's the work that we've been doing on a trusted research environment. And the other big program I'll mention is one to create federated cohort discovery across the UK. So I've been leading a project called CoConnect, which was looking for COVID data across the UK to try and create a dynamic federated discovery tool, and also then onto kind of federated analysis. And what we've done is we've embedded the tool into the HDR UK Innovation Gateway. And we've been working with a range of different, over 30 different data custodians to set up a virtual machine within their environments to enable aggregate level queries of what data they have and instantaneous answers back. So rather than sort of just saying, there's this database over here with 20,000 people who are diabetics, let's say. Instead, you can say, well, how many of those people are between the ages of 25 and 30 who've had insulin prescription in the last 6 months, and this and this and this, and that number that might be 20,000 whittles down to 3, and you realise you can't do your research question. So the whole idea with that is to try and streamline the research journey so people can easily find data sets out there. And I think we're just on the beginning of that journey that we've done for CoConnect. Now moving on to HDR, where we'd like to take that an awful lot further in the next 5 years. And I'll stop there. Thank you.
Great, that's great. Thanks, Emily. And finally, Shimon Rura, is a product manager at Verily. If you want to give a quick intro.
Yeah, thanks, Thomas. I'm filling in for David Glazer, who had some family obligations today. But I'm a product manager on the Terra team at Verily, and I also lead the product development on the researcher workbench for the All of Us research study. And so, the All of Us research program, as many of you know, is an NIH-funded initiative to create a cohort study with 1 million Americans, representing the diversity of our country, and really aiming to increase diversity in biomedical research data sets. David and I are part of the Data and Research Center within the All of Us program, where we collect and process data from all of the different organizations, the biobanks, the genome centers, participant provided information, all comes through the DRC, gets curated and presented in a cloud-based platform for researchers to use. The DRC, as part of All of Us, has really been built as an engineering organization. Today it was built from the ground up on the cloud. We provide about 3 petabytes of data to researchers. The dominant size there is the whole genome sequencing read data, but it's many different modalities of data built up over about the past 5 years. I think about what the cloud enables for us and where it's been challenging. Some of the challenges that we found are, that there are different security and policy concerns. I would say that overall with the cloud, you can do better, but it may be more complicated to get to a better, sort of security and policy enforcement, tool set. Another challenge is that many cloud tools are less familiar for researchers, and again, partly you can give them analogs where if they're used to running Plink on a local server, they can run Plink on a virtual server, and it works pretty much the same way. But there are some also some cases where in the cloud you're just trying to work with more data, and that can bring its own essential challenges. There's always the balance of usability and power for researchers as well. You want to enable researchers to do anything, but you also, if someone wants to do a fairly standard type of analysis, you don't want to present them with 1,000 choices that they have to make before they can get started. My colleagues have mentioned TREs, trusted research environments. I think one of the emerging challenges that's coming up with every cohort study potentially having its own dedicated cloud environment is that it is actually harder to bring together data from multiple cohorts and do the sort of large-scale co-analyses that will really get us to the next level of large-scale analyses and interesting scientific discoveries. And so I think a lot of the work IHCC is doing around building standards and encouraging interoperability can help to address that. But we're at the stage where the choice to build more stuff on the cloud is sort of generating its own second-order challenges. But I think those challenges way overshadowed by the critical benefits of working in the cloud. The chief one of which, when you're building, aspiring to build a data set of 1 million people's whole genome sequence data, for example, is just that there's very, very challenging to be able to work at that scale in other places, right? It would be challenging for us as a program, and I think it would be even more challenging for researchers who want to come in and use the data set that we are producing, because you just can't download a copy of that data and process it locally, except at a few major institutions, right? And of course, we want a level playing field where anyone around the world who has a scientific question that can be informed by this, can make progress on that without a giant capital fundraising hiccup at the start or challenge at the start. I also think that the cloud does enable better security for participant data, better than having copies around in different locations. It does provide significant cost efficiency, especially for storage. And yeah, I mean, there's just so much that we can make easy and approachable and well documented on the cloud that would be challenging to do if we were simply shipping out hard drives.
Great. Thanks, Shimon, for those points. So we've got our poll results, and I'll just quickly have a look at some of the answers. So first question we had is, well, the one I have results for, are you currently using a cloud for your cohort? We had 15 responses. And actually, we've got quite an evenly split sort of audience. We've got 5 for yes, using cloud for your cohort, 7 no, and 3 are partially. So again, it's quite a mixed group that we've got in terms of use or adoption of cloud, and you know, that's probably what I probably expected. The other question was, what's your current IT infrastructure? So again, we got 10 responses. We've got 2 out of 2 for public cloud, and again 5, the majority, is for in-house HPC. We've got 1 sort of ad hoc server under your desk, and 2 other, which I'm curious to understand what that is, but maybe we can get to that in the discussion. I think the interesting point, or the interesting question, was the open sort of question about what's your biggest concern about cloud usage? And again, I mean, I see, you know, privacy, security coming up. Data security really is coming up there quite a lot. Backup. Yeah, there's quite an array of different points here. So maybe we can actually maybe perhaps ask some of our panelists about some of these concerns that people have. So security, data security seems to come up quite a bit. I mean, I don't know if any of you on the panel want to maybe, you know, how you sort of manage that sort of data security concerns, because obviously it sounds like, I mean, it's certainly a significant issue for all of you actually. So I see Emily, maybe you want to take this one. How do you handle the data security concerns?
Yeah, so I think it's a really good question. But actually, we were concerned about it to begin with, on our journey, and we were concerned about how, if we wanted to do this, how it was perceived by our information governance people who had to sign off, you know, what we did, and I think part of the challenge here is people who are data custodians and sign off the usage of the data, they can understand, you know, the fact that you can have a box with locked cabinets on, and they can understand the sort of the different controls and things that you can put in place on your on-prem environment, maybe more than if that's in the cloud. And so part of it is actually explaining and articulating how the cloud actually still provides you with all of that data security. And one of the key sort of messages that we took away from this is, cloud provides you with all of the potential underneath, but it's actually your responsibility managing all of that to put that security bubble around. So it's not, the cloud provider provides certain things, you know, like ISO 27 certification, they provide all of the server rooms, they provide all of the controls on the staff access and things. But in using cloud, you need to put your security bubble in place so that the cloud provider can't get at anything, and that all of your data is encrypted, and that all of your policies and things are in place. But you need to do the same thing for that as you need to do on your on-prem solution. It doesn't mean that if you move to cloud, you don't have to still be responsible for all of those things. It is you who are using a service but need to provide that security level on top.
Yeah, interesting. So it's not like you still have the same responsibilities as if you had in your own internal systems, because you still have to secure the data from the institute, even in your internal system. So same problems, just move to a different infrastructure. Augusto, you want to?
Yes, I wanted to comment on 2 things there. One is, besides totally agreeing, I would add that one of the good things that the cloud brings is that they have quite a lot of functionality to try to evaluate whether you have the right security in place. There's a number of dashboards and tools that just explore your configurations and what's going on your firewalls, and alert you and gives you ratings of where you are. So in some ways that of course could be done on-prem or in your private cloud, but it's kind of easy to just get from the cloud straight away. And we could argue as to whether they are too stringent or not enough. But the main point I wanted to make actually is, I think we talk about security in 2 ways. One is the data being stolen and by a third party. And the one that perhaps concerns more people, well, that also concerns people, is that you don't want your data to be accessible by Amazon or Google or Microsoft or whatever else, or even worse, whoever is or their governments. So by that I mean the US could ask Amazon to hand over some of our data, and I'm sure they will contest it, but they ultimately have they are a company in the US and they need to abide by the rules. So the policy that the UK government has on this, we definitely have a cloud first approach. So if you're going to build any IT, you want to first start on the cloud, but you need to ensure a few things. And one of the key ones there is the idea of customer managed keys. That is that you control the encryption to your data. Therefore, if it's sitting at rest or as it's in transit, then you are the only one that can decrypt that and not on the back from the cloud provider. So that provides, I think, all parties, including the participants that have granted consent, with a level of, I think, clarity about what it means in a world where you don't own the hardware to control the data.
Great, thanks, Ugo. So Shimon, you want to?
Yeah, I'll just add, that when we think about how a cloud-based research environment operates, fundamentally, right, you're giving people that you've only connected to through the internet, access to run code that they provided in a space that has the data from your study, right? So you need to think about how do you balance technical controls that you can put around that access with sort of the personal identity verification and other things to make sure that the user is authorized, with also any sort of legal controls that might apply to give some recourse if a researcher's or a user's obligations in terms of keeping the data secure, keeping their access secure, are breached. And it's just a complicated new space, and so it is probably the most challenging thing about security is not necessarily getting it right, but proving that you've gotten it right to all of the regulating organizations and others that might need to be convinced that we're handling data responsibly. And so I think that is a challenge that is kind of its own set of competencies. Luckily, there are an emerging set of broader sort of security standards in various government organizations, and the cloud platforms I think are very familiar with navigating these types of things and can help cohorts who are struggling.
Great, thanks for that, Shimon. I guess it's kind of related. The other concern was privacy, but privacy security, I guess they're kind of related to each other, I guess, in some sense. I'm just looking again through the results, and actually now I look a bit closer. I mean, the usual sort of chestnuts come up, sort of, cost, true cost, making mistakes, basically potentially costly mistakes. And I mean, I'm assuming, maybe, well, the panelists can comment on this. I'm assuming that the cloud platforms have sort of ways that you can actually manage and reduce the risk of making these kind of expensive mistakes and getting a huge bill at the end of the month or whatever from your cloud provider. So, Emily, I don't know if you want to comment on this one.
My experience is that asking for consultants to help you at the beginning in order to try and work out how to architect a system that's going to give you the requirements that what you need and the cost. My experience is that they give you the requirements of what you need and don't consider the cost, because they say that, oh, we'll do some cost optimization down the line. And when you then go to do the cost optimization, you then need to tear up the original design that they provided in the first place. So I would very much recommend going into it with caution in terms of making sure that on any kind of requirements that you put in right at the very beginning, that you make it very, very explicit that costs are really, really important, and that any design that happens needs to consider those and not as a secondary factor to optimize later. Because otherwise, depending on how you set it up, there are big, big differences in the cost. And we've now resolved those. But it was a painful experience, I have to say.
This really sounds like learned by experience kind of scenario. So again, we'll probably come around to it afterwards, the question of what would you do if you were starting all over again, but we'll do that one in a second. So Augusto, do you want to comment on this sort of cost control and trying to get this right?
Yeah, yeah. Again, just an extension of the previous comment, perhaps on two avenues. The first one is you also need processes in place constantly to just be updating. We call it financial operations. In general, it's like, are you shutting down your test clusters at night? Those sorts of things. Or can we re-provision this with a better architecture? You need not just think about that you deploy the stuff and it's done. You need to have a constant monitoring function and improvement. The second point is more as a user, I'm worried about ending up using a whole bunch of things. So let's say I'm on Terra, just because Shimon can contradict me, but there are ways to put limits. So that's one of the benefits of such platforms that sit in between the kind of native cloud services and the user, such as Terra, that are able to control both the allocation of data, workspace side of things, but also like the costs. And you can say, well, I'm just going to give my student £1,000 a month and see how that goes. But also monitoring on costs is a lot more transparent. And it's not like at the HPC level that those things don't cost. It's just less transparent.
Yeah, I think that's the difference. I mean, when you're used to working in the kind of institute HPC environment, you just don't even think about what you're using. You don't need to. You just use whatever you need, and you just, I guess it makes you more aware that you have to kind of at least think about, you know, not just firing off jobs. You have to actually think about, is this the right analysis to do at the right time, and what scale it's gonna take, and how, you know, yeah. I guess it's just changing your mindset a bit more, I think, is probably the message here. I'm conscious of the time. We've only got maybe 3 minutes left. Okay, so if there was one thing, I mean, so what we've learned from the audience is a lot of people are still in the HPC but are potentially interested in the cloud for future. Certainly, Augusto and Emily, I think it sounds like you've gone from the HPC world and transitioned to cloud. If there was like one or two things that you would do differently if you were starting all over again, as kind of like, you know, if you're talking to yourself from like 3 years ago, whenever you started to convert to cloud, what do you think that might be? And I know I'm putting you on the spot, but if there was a lesson for any of the cohorts who are interested and thinking about moving to a cloud infrastructure, is there a nugget of kind of something you've learned that you would offer as advice, perhaps? Go for it. Which one of you wants to go for that one?
Augusto's just unmuted, so I wasn't sure if you were going first.
Ladies first.
so I just say, ensure that in your design, one of the primary things is the cost in that design. One of the big challenges we had was also about trying to use off-the-shelf services that were designed with an internet connection, but when you have a lockdown environment, you no longer have an internet connection. And so a lot of the things that we were doing were new and hadn't been already done by other people. And so there's a lot of really, really great stuff off the shelf that if it's very widely used and there's no customizations you need to do with it, it's brilliant because it's well tested by so many people and it's really mature. Trying to do something new in the cloud and an immature way takes more time than you hope it will. So just make sure you plan that in terms of timelines and things.
Augusto, go for it.
Sure. I think the first thing I would think is, do I need to stand up my own cloud environment, or is there a place where I can put my data already if I'm granted sufficient control over it? And so that is the like rent versus build it all yourself from scratch. And so I think that's definitely a good approach. And then the latter one is, if you do want to build your own, I think just make sure you have the right people. Alternatively, you get the right consultants, but it's a different set of skills than the ones that we would have had 10 years ago on building some tools around existing, the types of virtual machines and so on. So you need to have all those things in place. The people that will know about the platform engineering, the security, networking, and so on and so forth. It has changed a lot. It changes very quickly. So it's like a whole discipline that needs to be kept up to date, and that engineering and architecture needs to be around throughout the whole time. I'm not an engineer or architect. I'm not trying to sell sell the business to anyone.
I'll add one more, which is the importance of understanding scientific usability. So I think we have in the way we operate, we're always trying to bring engineering, science, and it's sort of usability together. And some of the most challenging parts of releasing a engineering artifact that is intended to be used for scientific purposes is not just sort of getting it built and making it accurate, but trying to get make sure that it can be used for the scientific outcomes that the people are after. And in finding a few of those people who can really represent the scientific users and work with your engineers as things evolve to make sure that it's meeting the end users' objectives are really critical.
Great, thanks. And unfortunately, we have run out of time, and I feel like we could probably talk for another half hour if we wanted to here, actually, with just the answers and the topics. I hope the panel is useful to everyone, and yeah, please, if you want to send more questions through the platform to our panelists, we can try to route them through to them. But thanks everyone for listening to our cloud infrastructure discussion.